nice thing is the solving is the same way we would solve an equation. So I'm gonna kind of focus on simplifying either side of this inequality. On the left side, I'm going to distribute. And I'm going to combine like terms, and I would get 5x minus 19. Okay, so that wasn't that bad. So now I have my inequality symbol. On the right side, same idea. I have x plus x minus x, and then that would be plus 4x plus 12. That would give me 5x plus 12. Okay, so that wasn't terrible either. Get my x's to the same side. I end up with negative 19 is less than or equal to 12. This is a special case because my variables canceled. There's no variables left. So I'm just saying, is this true or not?
It is true.
It is true because negative 19 is less than or equal to 12. If it is true, your answer is infinitely many solutions.
And on the graph, you just shade the whole thing.
You shade the whole entire thing. So you would just go, there you go. Because every single, you can plug any number in and it would make that statement true. I feel like we did no solution yesterday, so I wanted to throw that one up there just as a reminder of what it looks like. But they kind of randomly pop up, you just go through your steps, but when you see those variables cancel, that's your heads up that it's a special case. Number 2, we called a compound inequality, because there's kind of two parts of it. So we said in this case, we only have the variable in the middle, so our main goal is to isolate that. To do so, I'm going to go through my normal steps. I don't want this fraction here, so I'm going to multiply by 3 to get rid of that first. Whatever I do to the middle, I do to the right and to the left. So that's the big thing. Whatever you do to one section, you have to do to all of them. I end up with negative 6 is less than or equal to 6 minus 5x, which is less than or equal to 15. I still want to solve for x. I'm going to get rid of this constant next. So I'm going to subtract 6 from every piece. I get negative 12 is less than or equal to negative 5x is less than or equal to 9. And I'm going to divide. So now my x is isolated. I'm dividing to the middle, left, and right. And hopefully something goes off in their brain somewhere because I'm dividing by a negative, which means as I'm dividing those out, I am also flipping my inequalities. So everything flipperooed. And now we have 12 fifths, because 2 negatives make a positive, is greater than or equal to x is greater than or equal to negative 9 fifths. Your graph doesn't have to be fancy. Literally, I would put 12 fifths here. And if it's negative, it would be over here, negative 9 fifths. So you don't have to if you want to do all the in-between, go for it, but I don't care too much about that. Read from the x. X is, if I read it backwards, is less than or equal to 12 fifths. So that's
So you make it positive?
Because it was a negative divided by a negative, it would turn positive. So less than would be to the left here. X is greater than or equal to negative 9 fifths. So that would be to the right. So our answer is where they meet in the middle. So just as a heads up, there. So looking at those, whether it's just solving a regular inequality or solving a compound inequality, which are really the same steps, you just kind of do it to more than one section. Are there any questions that people have or any type of problem you would like to try another one out? Okay, so what we're going to do is go over absolute value inequalities. So that sounds like fun. We did absolute value equations a few weeks ago now. I'll give you kind of the rundown, what they'll look like, how to graph them, little things like that. And then we'll just practice a few. So not too crazy. But we want to get all the solving in this week. Next week, we're just going to look at some very basic word problems. It's more just looking at keywords like more than or no more than and stuff like that. So we'll do that. Then, sorry, I'm just trying to decide, or just trying to look at what we're doing. Oh, then after next week, then we'll just practice. Then it's Thanksgiving week, so we'll figure out what to do then. To make our lives not too terrible, we'll make it an easy week. So these are called absolute value inequalities. So let's start with one that's not too terrible. The absolute value of x plus 4 is greater than or equal to 7. So we have a general idea of absolute value because we did do equations. And same thing applies where when the equations we had 2 answers, same thing here. We're going to have 2 answers. Okay, we remember kind of splitting them up and doing a positive, negative, same idea. There's one little thing we need to add to that. So let's go through the steps and then we'll kind of look at, this is a greater than, we'll look at a less than one. These are a little bit different and we'll see how things go. So when I see an absolute value, just like with the equations, make sure your absolute value is isolated, so you don't want anything outside, so we're good there. So we want that to be positive, we're also good. We're gonna split it up. This first part stays the same, so I'm gonna just write the same thing. Just like with equations. For this first inequality, I keep that inequality symbol, and I'm just gonna keep that as 7. Like with the equations, I made the other one negative. I'm gonna do the same thing, but when I make that negative, I also have to flip the inequality. So for the second one, I flip the inequality, so I flip, and I make that negative. So that's the difference in the 2 inequalities. First part's the same, x plus 4. And then the first one, you keep the inequality with the number. The second one, you flip the inequality and you make that number negative. The solving is good. We know how to solve. We can do this one step, no problem. So we get x is greater than or equal to 3. And over here, we get x is less than or equal to negative 11. So there's some things we want to remember because there's a big difference when you have a greater than symbol or a less than symbol to start. So when I look up here, we say this is great or, I'm aggressively writing the or, that's not actually how you write greater, but to remind me, anytime I start with a greater than symbol, when I find my 2 answers, I put the word or in between them. So greater should remind you about the or. And then let's see what it looks like on a graph. Please graph it correctly. So this is always what happens. People just like don't think, they put a 3 here, and then they put a negative 11 here. That doesn't make sense. When you're putting something on the number line, we'll put the 3 here, the negative 11 will go over here, right? So just make it, it's a number line, negatives need to go to the left or positive. So just think about them individually. X is greater than or equal to 3. I'm gonna put a closed circle. I'm gonna shade to the right for greater than. Or x is less than or equal to negative 11, closed circle. That's a less than. Okay, everyone look at the board. Look. Okay, look at that. You looking at it? Okay, now look at me. What am I doing?
Rowing the boat.
And what do you row a boat with?
Oars.
Oars, get it? Don't those look like oars? Oh, they do. They do. Yeah, they look like oars. So greater, when you solve, you put or in between, and they're always going away from each other. So just little ways to remember things. But if you just actually graph that, you'll look at it every time. But that is what an absolute value inequality looks like when you start with a greater than symbol. There are some differences with less than symbols, so I'm going to show you that as well. And then we'll just look at one where maybe there's some extra stuff going on, because we know that stuff always happens. Maybe you have to rearrange a little bit, or something fancy happens. So we will look at one of those, and then we'll take a little break. But let's look at that less than first, just so you can see like what the heck is the difference. So let's say the absolute value of 2x plus 1 is less than 9. All right, so once again, nothing too crazy going on. We always want to make sure our absolute value symbols are isolated, which they are. There's nothing outside of them. So let's go through our setup. We want to split it up. So we have two inequalities. This first part, that 2x plus 1 is the same for both of them. So I always kind of write that first, just to remind myself. So then this first one, I always just kind of keep that, so I would have less than 9. And then I remember for the second one, I flip my inequality and I make that negative. So that's the difference. Okay, so it doesn't give us terrible inequalities to solve, maybe one or two steps. In this case, I'm just subtracting 1. I'm just going to do that right in my head. I'd get 8. And I'm dividing by 2. I would get x is less than 4. And then over here, if I subtract 1, I'd get negative 10. And divide by 2, I'd get x is greater than negative 5. So over there, we have the keyword or, because we started with greater. Here we start with less than. Get it, guys? Because you're going to put an and in the middle for this problem. Sometimes, and I think this might happen on one of your assignments at the end of the week, when you have an and problem, you can technically write it as like one compound inequality. So you can write it as x is greater than 4, and then x is less than 4, and x is greater than negative 5. Sometimes you'll see this. Right now you don't need to write it that way, but if you see it in the future, an and problem, you can write as like one big, long compound inequality. So if that pops up in the future, you've at least kind of had a quick thing. So let's see what this graph looks like. I know I have to have a 4 in here. I know negative 5 would be somewhere over there, because that makes sense on a number line. So just graph them separately. X is less than 4, so open circle to the left. X is greater than negative 5, open circle to the right. They meet in the middle. So I always remember less than, they hold hands, guys, okay? So less than, hold hands. Greater looks like ors. So just little quick ways to remind yourself of things. But that's the difference between starting with a greater than or less than symbol. It does kind of change a few things in how your answer looks with the either or and then how your graph looks. So does anyone have a question with kind of just those basics, the difference, how we're setting anything up, how we're solving, how we're graphing? Okay, so let's look at one that maybe, some other stuff is kind of in there, because we know that's going to happen. All right, so let's look at this one. Let's do 2 times the absolute value of 3 minus x plus 4 is less than or equal to 12. Okay, so I'll do this one with you. Then we'll take a break, and then I'm going to have you guys try one or two just to see, is it making sense? Can you do it on your own? Do you have any questions? So we notice some stuff is added. Hopefully this looks semi-familiar from when we did equations. Basically what I want is I need this to be isolated. AKA I need that to be by itself. I don't want that 2 there and I don't want that 4 there. So we have to do a little rearranging first. Please do not on this step start splitting things up. You can't split it up until that's isolated. So first thing I'm going to do is subtract 4. Let's get rid of the constant. What's that going to be 8? I still need to isolate it, so that one step was great, but I still have that 2 in front. Remember, we do not distribute into absolute values. We are going to divide both sides by 2. Okay. Main goal is make it look like the problems that we just did. So you might have to do a little bit of rearranging, but isolate as your first step. Now we can split it up. I'm going to get 2 inequalities. 3 minus x is less than or equal to 4. 3 minus x is greater than or equal to, because I flip it, negative 4. Okay, so let's see if you're paying attention here. Subtract 3, okay, feeling good. negative x is less than or equal to 1. To get this x by itself, I don't want that negative, you can always throw a 1 there if that's confusing you. You would divide by negative 1. My rules of inequality still apply, and I just divided by a negative, which means I need to flip this inequality. So those little other things with inequalities are still popping up with absolute value, so just be careful. Subtract 3, I get negative x is greater than or equal to negative 7. I'm gonna have to divide by negative 1 to get rid of that negative, and since I divided by a negative, it flips my inequality there as well. Let's just check. I just want to check because the flipping sometimes maybe messes things up. So let me just look. I'm going to have negative 1 on here. I'm going to have 7 on here. That says x is greater than or equal to negative 1. So close circle to the right. That says x is less than or equal to 7. So close circle to the left. It was a less than. They held hands. So make sure you put that and in the middle down there. And you got your nice little graph scheme. So we saw kind of the basics, okay, greater than, less than. What do we do? Our general steps. And then we saw one where maybe a few things were added. Things like having to isolate the absolute value. Things like when I'm solving and I'm dividing by a negative. Does anyone have a question with that problem or with anything in general at the current moment? Okay. Okay, so if I asked you to solve and graph the following.
How many are we
I'm just
doing?
gonna do one for now. 'Cause
Okay.
I don't wanna do 2 and then run out of time. So if we have extra time, we can. Solve and graph. So here's your inequality. 3 plus the absolute value of 3x minus 1 is greater than or equal to 13. 13. Okay, so nothing too crazy going on. You would have to isolate your inequality before you split it up, so just be careful that you always do that first. Once it's isolated, you get your 2. You go through and try to solve your x.
Since it's plus, would you subtract it or would you
You would
divide it?
subtract 3.
Okay.
Yep. That's what you guys do. Another minute or two, see how far you get, and if your questions pop up, let me know. Today, 11. Oh, hey guys, today's my anniversary.
Happy anniversary.
Thanks.
Yay.
Married for years. I literally. All right, looks like most people have finished up. So let's just go over that, and then we'll only have a few minutes left, so we'll kind of just pack it up from there. So few main steps. Isolate first. So I'm just going to subtract that 3 because it is kind of addition. So we have the absolute value of 3x minus 1 is greater than or equal to 10. Now I can split it up. 3x minus 1 is greater than or equal to 10. 3x minus 1 is less than or equal to, because I flip it to negative 10. Add 1 to both sides. 3x is greater than or equal to 11. So x is greater than or equal to 11 thirds. Fraction's fine. Sometimes I just made up kind of random numbers. In this case, when I add 1, that will give me negative 9. So x would be less than or equal to negative 3. Greater. So I put an or in between. So what do we got? 11 thirds, I'll kind of just throw over here. It doesn't have to be perfect, but negative 3 should definitely be over there because negative is always to the left of the positive. We're saying x is greater than or equal to, so closed circle, shaded to the right, 11 thirds, and less than or equal to negative 3, so I'll do it to the left. And we know with an or problem, this should be going away from each other, looking at those ors. And that, my friends, is your final answer. Does anyone have a question of that problem? Beautiful.